Cool. Oh, thanks everyone for coming along. So we've gone from the heights of Unreal Engine 5 meta sounds to the not quite so heights of Unity Audio. But don't worry, because we can do good things with Unity Audio, and well, that's sort of what we're here to look at today. So, without further ado, this is kind of an outline of what we're going to be looking at today. First, what you need, probably more aimed at programmers, but perhaps useful if you're brought onto a Unity game. You're like, hey, these are the things that you need to get into your audio now if we're not going to go with middleware. Basically, Unity's missing a bunch of, I would say, like key features that you just absolutely need to make good sound. Next is what you might want, especially if you're not going to go with middleware. You can't have everything. You're going to need to be like quite smart as to what features you want to add, and that's going to depend on the game. So this is going to be a bit of a suggestions of some of the stuff that I've added to our games that have helped to bring it up to a higher level of audio fidelity, and kind of give you an ideas of like what's kind of possible within the tools that we get with base Unity. And then the last one is kind of a few extra bits and bobs that don't really fit into either of those. A few tips and tricks and a little bit of extra stuff from our game Stationeers. So that's my lovely face. This is a little bit about me. So I started off as, I think, almost everyone in this game started off doing music. I studied music at uni, finished that in 2010, and then spent sort of about 3 or 4 years in construction and landscaping because no one wants to hire a music graduate. So I moonlighted as a composer for as long as I could. Eventually found my way into a career working as a composer for TV and nature documentary, and then started going into game audio around 2016, and started at Rocketworks in 2018. And currently my role there is looking after all our Unity projects. In my spare time, I'm really into rockets, and I play a lot of Apex Legends. So these are the games I'm working on right now. Stationeers, which is we call it Minecraft for nerds. I guess is one way of looking at it. It's multiplayer, sandbox, survival. It's got physics simulation. We do some thermodynamic stuff. We simulate atmospheres, atmospheric pressures. We do some basic ideal gas law kind of physics stuff with our gases. So players have to basically build a station on Mars or Venus, which is really hard, and survive and thrive. Out of the Rail, which is, you can watch Dean Hall making on Twitch sometime if you're interested. It's a multiplayer transport tycoon game, and it's basically open TDD but 3D. It's a nice project to work on that has a really tight design brief. So that's well on its way. And then Torpedia, which is another game that's probably coming pretty soon. This is a pretty exciting game as well. It's been in development for a while. It's a building exploration submarine game, and thank God this one's single player, so I don't have to worry about replication. So why Unity Audio? Which is a question I asked myself when I first started here, because I was like, hey, we should use Fmod, and Dean was like, no, it's too complicated and too expensive. And I guess the first main reason is, hey, it doesn't cost you any extra to use Unity Audio. You get it for free already. And at a certain stage in your company, licensing a middleware is actually, almost the cost of a team member. So that's money out of your audio budget. So if a studio of 3 or 4 people is saying, hey, we've got this game, it's got a budget of $1 million, $1.5 million, how much should we spend on sound? Well, you could say, well, you could license Fmod or Wise, and that's gonna cost quite a lot of money, but instead we could put that money somewhere else. Sure, you might have to do a little bit more programming, but you like to do that anyway. and instead maybe we could spend that money on, I don't know, hiring an orchestra, or I don't know, maybe spending more money on sound design. So I just as a way of thinking of it, I guess it's not always you don't always get a fixed portion of the pie, but it does leave more money for the creative side of it. So that's the first main reason. Then there's integrating and maintaining, which depending on your project can get quite complex. It restricts you in how you design your sounds. So FMod and Wise have ways of doing things, and while they're incredibly flexible and powerful tools, they also force you to sometimes work in a certain way, and maybe that doesn't work for your project. So for the reason we do Unity Audio and Stationeers is because that was the way it was when I arrived, and that was the way it was going to stay. So I just had to work with what was there. The game was already out in early access. We weren't going to swap out the audio renderer at that point. So I had to do some very careful refactors to try and get the features I needed into an early access game. Torpedia, a small experimental project. We weren't even sure if this one was going to be more than a learning game for juniors, so we weren't wanting to spend more money on it. Art of the Rail is a bit different in that the heart of the game is about modding. So we wanted our game to be as moddable as possible, so all our sounds are in XML. And it's really easy to add a new sound to the game, and if we use middleware for that, we wouldn't necessarily have that same level of flexibility in our tooling. It's a small, simple game, and we wanted to keep it as risk-free as possible. This is what I like to call the stages of grief of working with Unity Audio. Shock and disbelief, pain, bargaining. This happens a lot. You go to the site and it's like, oh, that's just the tooltip, thanks guys. Depression, reconstruction, and then hopefully hope and acceptance. This is where we're hoping to get to by the end of our talk. So now into the sorry, that was the largest picture I could find of the Unity audio source. I think that's like 24 by 24 pixels. All right. Okay, so this is probably a slightly dry section. The first thing you're going to need is an AudioSource wrapper. So it's a mono behavior that handles the game's interaction with audio. Because your audio source is missing a bunch of stuff, and you can't inherit from AudioSource because of the way Unity likes to handle its code. You can't just go in there and play with it like you can with Unreal. So you want a wrapper class for your audio source, and you're going to put all the extra stuff you need in there so that when you go play a sound, you're not talking to the audio source directly, you're talking to this wrapper in between that is going to do the extra cool stuff you need. Some of the things you're going to need to do on that are store the original state of everything so that when you change something on the audio source, you can go back to what it was. You're going to need methods to apply data to it, because we're going to need to make some new data classes as well, and we're going to need methods that handle the new functionality we want on it as well. Who here works in Unreal Engine audio? Cool. So an attenuation is a term I've grabbed from there because it's a really helpful way. It's basically it's a set of data that says this is how a sound behaves in the world. And Unity Audio has that, but it's integrated within the audio source itself. So you can't just like apply a setting to an audio source. So we're going to need to create an attenuation class basically that has all the data in it that we can say, okay, I want to play a sound and I want to play it with these settings. And we're going to need to, because Unity doesn't provide a way of sharing settings between audio sources, at least as far as I've been able to work out. So you're going to need a way of serializing that data, like storing it, saving it, and you're also going to need to have a way of applying it. This is pretty high level. I'm not going to say how to do it, but it's kind of like these are the things you need to sort of think about when you start getting into the sound side of things. The last one, you're going to need a wrapper class, data class for your clips. So an audio clip is currently in Unity, an audio clip is a sound file, generally a wave or something, and it has a bunch of settings associated with how it's handled on load and in memory, but it doesn't have any behavior associated with it. So we want to create a clip wrapper class that allows us to assign behaviors to clips. And again, I point you towards Unreal Engine. Have a look at sound cues, and we're going to look at making something that's not as cool as that, but something that can do some of the same things. So for example, my clip wrapper class in Stationeers allows me to, say, have more than one sound. It allows me to specify is that sound looping or not, should that sound fade in or fade out, should that sound have random pitch or random volume. And I can assign that in when I set up that data, rather than having to program that on every time, program that sort of piecemeal throughout the code. So it turns it into a design problem rather than a coding problem. How will you input your audio data? At Rocketworks, for better or worse, we use XML. And I've come to get quite good at it. It's okay. On Other we're actually moving to making our own in-game tooling to deal with XML, which will be a blessing once that's done. But the nice thing about it is at least it's sort of separate from your code a little bit as well. The other option is you could put it straight onto a prefab, but that feels a little bit less, a little bit more vulnerable to maybe something breaking. Or you could actually build your own Unity tooling as well, and they're actually pretty good support for making your own editor tools as well. And how will you serialize it? You decide, yeah, we use XML. The other thing to briefly consider is memory management. I would say just keep it simple. You're working in a Unity game, you're probably not, if you're working in a Unity game with Unity Audio, it's because you're a small studio. So don't try to do anything too complicated with your sound that's going to require difficult memory management. In all our games, basically everything gets loaded into memory unless it's streaming from disk. And because everything's sandbox, everything gets loaded at the start of the game. So I just have to make sure that my sounds don't exceed the appropriate amount of memory that's allocated to me, which is not necessarily a fixed value, but people start looking at you if you're taking too much memory. This is probably the most important thing that I want you to take away, is pooling. Unity doesn't handle this for you. You can't just say, play a sound. And Unity's like, cool, I'll put it over there. This is something you have to handle yourself. So having lots of audio sources in your game is going to add overhead. So every audio source in the game that's active runs an update. And it's fine if you've got like 200, 300, but if you've got, like when I first joined Stationeers, I think we had maybe 2,000 or 3,000 audio sources, because there wasn't many things in the game making sound at that point, because it was very hard to get a sound to play. But everything that might play a sound had an active audio source on it for each sound that it would play. And that was actually taking a decent chunk of frame rate. So that updates run on the game thread, it's not run on the audio thread. So I sort of have a general rule of thumb of like, we don't want more than about sort of 200-300 active audio sources in the game. So having a component pool of like audio objects is a really good way to go. And you don't want to be destroying and creating audio sources every time you play, because that generates garbage and it's bad. So this is basically like a queue of game objects that you say, I want to play a sound, you grab it, you pop it on the transform where it's supposed to play, it plays the sound. Then you have to add it to a list of sounds that are playing, and you've got to check over that every now and again, because Unity Audio doesn't have a callback for when a sound's finished, so you're going to have to go, are you playing? Are you playing? And it's like, nope, so you pop it back in the queue. And I normally make that about twice whatever my voice limit is for the game, but you might want to have some logging in there that says, hey, I tried to get a voice and there was none available. But that's a good way of handling the amount of stuff in the game. So these are really useful for what I would say like transient sound behaviours, so something that come and go real fast, and large numbers of game objects. So the perfect example for good use of pooling is physics collisions, especially in a game like Stationeers, where people can just spawn in dynamic objects as much as they like, and they bump into each other and make sound. I don't want to have an audio source on each of those things to make their collision sound. I can just say, oh, you collided, play a sound there. And I talked about that. A system for tracking when sound's finished. Yeah, you'll need to work out a way there. So the best way I have found so far is just to iterate over a list and ask them if they're playing. If someone has found a better way, please let me know. Right, pitch and volume multipliers. You're going to have multiple reasons to change your pitch and volume, and you can do that on an audio source, but then that's it. That's the volume and pitch of the audio source, and that's not very helpful when you have you wanted to say, okay, this audio source is nominally at 0.5 volume, but actually it's a bit loud, so I think it should be at 0.3. But then if you have something else that's changing the volume, that's gonna stuff it up. So this is basically a set of properties on your audio source wrapper, and whenever you want to change the volume, you're going to change one of these volume multipliers, and then your audio source wrapper is going to evaluate all the different volume multipliers, multiply them together, and then apply them to the audio source. And they are your friend, and if you don't do this at the start of your game, it will cause you pain later. So I really encourage this. And so, for example, in Stationeers, I have the source volume, which is the volume that I've decided that the audio source is going to play it. That's on the attenuation. Clips volume, which is attached to the clip. Occlusion, so if something's occluded, it's got a volume multiplier applied to it. The fade in, fade out, I use a volume multiplier for that. You could create your own sound glasses. I haven't done that, but it'd be a nice thing to do. You could have sound glass volume, and also just a dynamic one that's available for game logic, so that I can say, when this thing happens, drop the volume of that audio source. Basic functions. Fade in, fade out, delay. Yeah, Unity doesn't come with a fade in or a fade out, which is really dumb. So you're going to have to write one, and you're going to have to do it on the game thread, I'm sorry, which is kind of annoying. But just remember to put that in there. It's probably going to use a while loop, which is risky, but just make sure your exit conditions are really clear and you can't fade in and fade out at the same time. You're going to need support for multiple clips, and you're going to need to support probably some sort of randomization, and this stuff is going to be in your clips wrapper. Might power through this one pretty quickly. Setting up an audio source game object. So we've got this is the spatialization curve for the audio source. You've got 4 different things: volume, spatial blend, spread, and reverb zone mix. And they're actually quite powerful, and you can apply these all with curves. But you can't save this data anywhere to apply it somewhere else. So this is what I was talking about, your attenuation. You want to create a way of serializing a setting that you really like, and then being able to apply it to an audio source ad hoc. So I tend to use animation curves for this, and I will find a setting I like, then I will save that animation curve, hard code it, and then I can just and generally store those as like a setting in a dictionary or something, and then I can say, hey, this type of audio uses this is what I like to call this is the less linear volume decay curve. So it's kind of like it's not quite linear, it sort of scoops off quickly, so it gets out of the way, but then stays around for a bit longer than a linear one. I find that works quite nicely. So I've got that saved as a preset, and I just can set a max distance, and it applies that preset over that distance. It's the reverb zone mix up there, which is the yellow one. The green one, spatial blend, is super helpful. That's a good way of, that's like your, what is an F-mod? Is it the minimum distance in F-mod, where it plays as completely 2D until you're past that point? And then the last one is spread, which we are not using today. I only tend to use that on I think I used it on a Rocket because I had like a stereo file that I wanted to play, but at a certain, that's how wide it is in the stereo field. Yep, we covered all that. I don't know if you need a manager you need an audio manager. Just don't call it audio manager, because Unity already has an audio manager, and don't call it audio manager script, because that's a really dumb name, but I can't change it now. I kind of like, we're sort of moving away from, okay, so it's good. Definitely you need something to track all your audio sources, and you probably need something to manage some of the bits and bobs you're doing, but probably most of it can be handled with like static methods and collections on your classes, on your like, maybe your audio wrapper class itself. But I think in my audio manager, I sort of handle occlusion and pooling and that sort of stuff. But yeah, just be aware you've got to handle that stuff. Right, now we get to the slightly less dry part of the talk, and I'm sorry I didn't include pictures of every slide, but this is a cool slide from Stationeers. This is an example of why you might need concurrency. So these are all things bumping each other. Some poor soul has ended up with way too much iron and gold in their base, and they haven't stored it properly, and it's going to be tanking their frame rate because of all the physics. But we don't have 1,000 voices available, and we actually want to hear some of the other sounds in the game as well. You kind of have a couple of ways of approaching this in Unity. Obviously, you don't get a nice concurrency system like you get in Unreal Engine, but you can definitely go and look at it and try to copy it like I did. But the first thing you want to do is use Unity's priority system, which is a very blunt instrument. It's basically, if I have a higher priority, I always play, or rather, if my priority is closer to 0, I always play then a sound that's priority is higher than me, or above me. So a sound with a priority of 0 will always play before a sound with a priority of 1. And so I tend to use priorities for sounds that I always know should play, and they're not going to be voice hogs. They're not going to be a sound that's going to be replicated 30 times or something. So always for UI, ambience, music, and maybe interactions that I always want to hear. So that's the first step. The next one, I think, is using effective spatialization. So if I put a really steep curve on these sounds, Unity automatically will assign them a lower priority because their volume is lower. So Unity's internal black box of handling what sound should play assesses which sounds it thinks are the loudest, and that's purely based on the volume of the audio source and the volume of the channel that it's attached to, and it'll play the ones that have the loudest perceivable volume. So you can kind of get around a little bit like that. Or you could say, if a sound is more than X distance away, just don't play it at all. But at a certain point, maybe you need to go to, I really recommend looking at Unreal Engine 4's concurrency for inspiration, because it does a really good job. And you can basically set a concurrency, which is has a rule, so like stop the newest sound, stop the oldest sound, stop the furthest sound, and whether it should pause or whether it should stop altogether. And then different clips can assign themselves, can sort of subscribe to it, and then when a sound plays, it's like, hey, am I allowed to play? I'm going to evaluate this rule, and if it's true, and if it's true for all rules, then I will play. But there are performance considerations, because you're going to have to do a lot of this on the main thread, unfortunately. So I currently do it every 200 milliseconds. It can get expensive, so for example, I put one on the solar panels moving sound once, and people built 100 of them, and it was evaluating them every time a solar panel sound played, which was 200 times, and so I'd get like a 20 millisecond spike. So I was like, okay, I have to handle this a different way than my not so efficient concurrency system. One thing you could do is maybe spread out the work, so evaluate each concurrency, each frame or something. Occlusion, which is pretty straightforward in Unity. You want to use Unity's layers system, but just watch out, because layers is also used by lighting and physics. So I ran into some issues at the start when I started implementing it. So you're treading on a lot of other people's territory. So I made a block sound layer, and I basically had to pop my own special colliders on their own child game objects within anything that I wanted to block sound, which in Stationeers is not a huge amount. It's basically all the wall and window and frame pieces and doors. So it wasn't a huge undertaking, but it meant I had absolute control over what things could actually block sound. I also used that same layer for calculating the size of the room for doing reverbs, which I'll talk about later. But we use physics.raycast. Don't use raycast at all because it generates garbage and it's more expensive. And in Stationeers we have a dictionary of every collider in the game to everything in the game, so I get the collider back from the raycast and I ask it, are you the thing that's making the noise? And if the answer is no, then I'm like, okay, you're blocking the sound. And then I can apply a multiplier to the volume. But you're going to need to optimize this. You can't just throw it in willy-nilly because you're going to get in trouble for doing too much physics. So the first thing you want to do is only do this on sounds that are non-virtual. So you can ask an AudioSource, are you virtual? Which means, hey, I'm playing a sound, but Unity's decided that I'm not important. And if Unity's not rendering the sound, we don't want to do this physics check on it. We also do a dirty hack in the mixer, where if something is occluded, we swap it to the occluded channel, which has a nice EQ on it that makes it sound muffled, and that means we don't have to have an EQ on every audio source. We also do something, sort of a faux occlusion, where for objects that are going to have to maybe do this a lot, because I have to do this check every time a sound plays. So for sounds that play a lot, like the music machine I'll show you later, that gets a bit expensive. So instead we just ask, are you in the same room as me? And if you're not, then be occluded. And that Stationeers is a nice system for working out a room. Again, you might want to spread out the work. I haven't done this yet, but I sort of ping every sound that's currently playing every 200 or so milliseconds. But maybe I should do that in little parcels. But currently, it's not eating too much of the frame rate. All right, here's a good example why you need occlusion. So we've got a base here with it's a stress testing base, it's not functional, but it's just got a lot of stuff in it. And if we didn't have that stuff blocking the sounds, it would just be an absolute cacophony because everything's going full blat. So if you have a game where you might potentially get a lot of things playing sounds close to each other, occlusion's a really good way of managing how cluttered your sound field is. And the nice thing about a game like this is it allows players to manage themselves. So if they've got a noisy machine, they can pop it behind a wall and make it quieter. And it's a nice way of giving the player agency within the sound of the game. Dynamic reverb. This was a fun one to add. And this also there's also a picture of the organ that I added to Stationeers as well, which is mostly for fun. But this one plays the theme from 2001: Space Odyssey. You've got to pump gas through it using an atmospheric system. Reverb. So because this is a fully dynamic game, we can't just plop reverb zones around like you would on a static level. So the first thing you do is just attach the reverb zone to the player because the reverb is just local. We don't need to replicate anything. And then I measure the space and I just do a bunch of raycasts every now and again, not too often. I think I do 10, and that gives me how far away is a block sound, or a terrain. And then by looking at that data I get back, I say what kind of a space am I in. I can look up and see if I'm hitting a terrain layer above me, then I'm underground in a cave. So I want to use the cave preset. If two of the parallel spaces next to me are quite tight, I'm in a hallway, so I'm going to use a hallway preset. and then I'm also sort of do a bit of a approximation of how large is the spaces based on all these different raycasts, and that's how large the room is. So I'm essentially flip-flopping between about 6 extreme presets, so like small room, small hallway, large hallway, small underground, large underground, and outside. So here's a kind of an example of that, and this will need to be quite loud because it's quite quiet. Oh, and then I loop between the presets as well, so it's not sudden. So you'll be able to see the next video has a picture of Unity showing what's going on real time. Yeah, I thought I was going to have to make a tool to ping a space, but it turned out the switch on that drill was really helpful for that. A music stitching system. So keep it slim and always prototype an Fmod because it really has the best tools for creating interactive music systems. But we don't have Fmod today, so but it's a real pain to implement something in code and then realize it doesn't work for your music, because sometimes you don't know how a music system is going to work until you actually get it in. But you can kind of simulate an Fmod first. So even if I'm working in Unreal, I'll probably still work out how my music system is going to work in Fmod first, because that takes half a day, and then I can do the hard yards coding it up, and I know that the end result's going to sound good. But let's not get too complicated because we don't have great tools for this, and we're going to need to build everything ourselves. So pick what's the thing that's going to make my music system work the best, or maybe we do what we do in Arted Whale and say, hey, we're just going to have a playlist of tracks. Make sure you use play scheduled. It's probably one of the best things about working with Unity Audio is you can schedule a sound to play on a specific frame of the audio thread, but you don't necessarily know what frame you're on. So you kind of need to do a little bit of calculations. So if you say, okay, I played a sound on this frame, I told it to play a sound on that frame, you need to cache that, and then come back later and say, well, now I need to do a calculation as to how far away it was from then to then, and then play a sound on the next frame. So there's a bit of math. And yeah, I would pick what kind of stitching you're going to do and just stick to it. Don't try to get too complicated. I mean, in Fmod you can just chuck in I'm going to use a transition point here, I'm going to transition by beats here, whatever, blah, blah, go crazy. If you're doing something in Unity, just pick one. Either maybe have transition points within your tracks where you transition, or maybe you just do beat and bar switching. And I suggest maybe making a child class of your clips wrapper that contains that extra data. And you might possibly need to make a child class of your audio wrapper as well that handles maybe a bit of the extra functionality around music. But it's perfectly okay to just not have a dynamic music system. Keep it really simple. The more I've been working with music in games, the more I've realized it's more just about having great music. And it's really fun to get into the tech of how it interacts, but at the end of the day, often you actually end up with a worse result because you're doing something creative because you can, not because you should. So that's my, coming from a background as a composer, you can get a little bit too excited about this sort of stuff, so you've got to dampen it down. All right, this is what we did in Stationeers. That's an LFO there. be honest, this is something we did because we could, not because we should. But we have this great logic system for hooking stuff up, and I was like, what if we made like a modular sequencer, and sort of managed to shoehorn it into the existing logic network, and it kind of doesn't quite work in real time because the logic network ticks every half a second, so we had to do a little bit of sort of a little bit delayed. But you can also set the BPM and you can write the BPM and time to these things and hook them all up together and make fun sounds. But it's one of the examples of one of the things that's possible to do in Unity, even if you don't have the greatest tools to begin with. Lastly, where are we up to? Oh, we've still got a bit of time. Tips and tricks. So fast iteration is king. I went to a really good talk yesterday about writing trash code. I can't remember who was the speaker, but he made a good point about which I want to talk again today. Make sure when you write a system for a sound designer, or you're an audio designer and a programmer is writing for your system, make sure they expose all the magic numbers as public variables or as private serializable variables, so that you can go into editor and play with it all, because you'll be trying to make a sound do something based on an input from the game, and sometimes the input will be wacky and you'll be wanting to just assess it over a small aspect of that data, and you'll generally have to use some sort of number to say, okay, if it's below this threshold, ignore it; if it's above this threshold, ignore it, and then do the volume or pitch modulation based on the delta between those numbers. And if those are all hard-coded, it makes it really hard to kind of tweak that real time. But if you expose an editor, you can load up the game, you can play around with those settings and get it so it's sounding good. A good example of this is like we have like a robot in the game and it's got legs, and we play like a rank 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 sound based on the rotation of the thigh bones, I think. But you get some pretty wild values when you're reading that. So I use an animation curve for that, I think, which is my next point. Use animation curves. They're really... here's an example of an animation curve used to make opening a gas bottle sound. So we've got two layers. We've got a loud sound and a thin sound. And then we're also modulating the pitch of the thin sound using that one here. So I want to get that sound, when you open a gas bottle and you kind of edge it and it goes psst. Then when it's fully open, it makes this massive whooshy sound, right? So that's what the loud layer is for. And that's something I could have never done without being able to tweak it real time, because you need to iterate over those curves quite a lot. But they're unruly. They're trouble, and I've run into a lot of problems with them, but I keep using them because they're most useful. So Unreal allows you to save a curve as an object, which would be amazing if we could do that in Unity, but we can't. They're a bit of data on a prefab, or they're a bit of data hard-coded. But yeah, we can use them to tweak dynamic audio responsiveness. Okay, so there's a couple of ways of kind of dealing with them. You could save them all on like your audio manager prefab, maybe on some singleton prefab somewhere. It's like, this is where I'm going to store all my animation curve data, which is okay. At least it's good for tweaking and editing and sort of like refining them. But at a certain point, you're like, okay, my curves are good. I'm happy with how they're performing. It's probably better to hard code that value in code so you know it's not going to disappear. Because if you like change the name of that variable, Unity deletes the data. If your prefab gets corrupted, that data's gone. You might be able to get it back via source control, but prefabs can be a bit sketchy sometimes. So it's much better to just, each of those curves is made up of little nodes that have 6 bits of data that specifies how they behave. So you can just save an animation curve as basically a string of numbers. And you can find those magic numbers basically by opening up the prefab in your source control and just seeing, and it'll give you the list of all the point data. But after a while, you get pretty good at just kind of eyeing it up. But if you're working on one and tweaking it in game, and you get it sounding perfect, and you're like, sweet, and then you press the play button, and then it goes, and it's gone because it hasn't saved it. So what you need to do, this is the most important workflow for working animation curves, is you make it, and you're like, okay, that's really good. Then you have to make a new one over here in your presets, and then you can close your game, and then you can go back to it, and you can apply that preset. That's the best way of working with them, and it's a bit janky, but it's worth it because you can get some great interactive sounds. The mixer, what is it for? In my opinion, not what it says. It's not for mixing your game, and I don't like to use it for that because it's not like Unreal sound classes where it's sort of calculated before the DSP. This is sort of DSP stuff. So it's the more channels you have and effects you have on it, it's going to put strain on your audio thread. So you can't do too much with it. I tend to think of it, hey, this is for players to mix the game, and then it's for me to do a couple of like very broad mix things. But I prefer to use more like a more granular system for actually mixing elements together. Yes, that's what it's not for. Use exposed parameters. They're really helpful. I think you just right-click on it and say expose, and you have to give it a custom name in the exposed parameters drop-down, and then you can set them from code. So we do lots of cool stuff in Stationeers, changing various things on the mixer by changing those parameters. Snapshots, I don't like them because it's really easy to, you can be playing around with the mixer and accidentally break a snapshot, not realize you did it, commit it. There doesn't seem to be a clear way of managing them in a way that, I guess they're quite fragile and quite broad. You could maybe use them in a very limited sense, but I don't know if they play very well with exposed parameters either. So you kind of got to pick one or the other. In Stationeers, we use the mixer for listener perspective. So opening and closing the helmet does a bunch of stuff. We use it for whereabouts of the sound, because we simulate atmospheres. We simulate the atmosphere inside your suit. We look at the atmosphere that's directly around you. So if a sound is playing external to me, it's on the external channel. If I'm holding it but I'm wearing a suit and my helmet's closed, it's played on the internal outside channel, and a bit of the sound comes through the suit. Or it's played inside my suit, in which case it's played on the internal channel and is affected by the internal suit atmosphere, or it's played on the internal no effects channel, which is like, it's just in my head and I don't want to change the volume based on anything to do with the atmosphere. And we also use it for occlusion and a dirty hack to save DSP. And this is kind of how some of that stuff works in Stationeers. So it's opening and closing the helmet, and what we're doing is moving the sound around using sends to run it through different effects channels. So when the helmet is closed, the external stuff is piped through the helmet effects send. And when the helmet's open, it gets bypassed and goes somewhere else. You can kind of see what's going on here. This is a really dirty hack. So Unity evaluates the importance of a sound based on the volume of its channel. But we're actually sending that sound to helmet closed before we're applying the attenuation. So Unity thinks that the sound is quiet. So we can't just turn the volume down. Instead, we just apply a very broad EQ, which just cheats Unity out of thinking that the sound is quiet. And now I'm taking all the atmosphere out of my suit. So you can see here the filter on the internal suit atmosphere. And also going to stop breathing.
Critical. Temperature critical. Cognition low. Low pressure.
now we're going to walk outside onto Mars. So you'll see the external channel here change with the external atmosphere. And so we're at what, like 2 kilopascals out here. So there's not as much sound. So the volume's a bit quieter, and we roll off the highs. But it gets a bit loud if we open a helmet, which is not recommended, but whatever.
Pressure critical. Oxygen critical. Low pressure.
Yeah, so that's kind of I guess a bit of a sampling of like one way you can use the mixer. And that's it from me today. We have a little bit of time for questions if anyone has anything they want to throw at me.
Please wait for the mic if you have a question.
Yeah. In terms of conserving memory, is there a certain file format you prefer? WAV or FLAC or something?
So for out of the rail, we make a rule that if a sound is longer, if it's a mono and longer than 5 seconds, then we use OGG. If it's more than 5 megabytes, we make it shorter in an OGG. And then if it's shorter than 5 seconds, we use a WAV. So WAV uses less. You don't have to decode it, right? So it's cheaper. And if it's a music or an environment sound, then we'll stream from disk. And you'll still want to use an OGG, because otherwise it's just going to take up too much space. Like you don't want to be storing your music as waves, unless you're shipping a CD with the game with a soundtrack in 2000. Yeah. Sweet.
Thanks. When you talked about pooling, you were talking about creating game objects and playing them, like if there's an interaction sound,
Yeah.
Assuming that you're moving that game object that you just like set active to that point where it was made, right? What about when it is a sound that's like, let's say, I'm not sure if this is in the game, but somebody like springs a leak, and that sound is moving with them. Are you parenting it, or is there a... Okay.
Yeah, so if it's... you have a couple. Like you can either play it at a transform, right, or you could parent it to a thing. Just make sure that when you've seen that it stop playing, you unparent it and parent it back to the pool. Yeah.
Have you investigated the difference between actually pooling the game objects and doing add component and destroy?
That tends to generate quite a. I think it has a lot of allocations. It's got a lot of overhead, so we tend to avoid doing that for sounds. I think it's quite expensive.
Okay.
Yeah.
I have a question from the app here. Very helpful talk. Have you considered putting this code in open source library? Although that sounds like a lot of unpaid work.
Ask Dean Hall. It would be good to have one, because I think there are a couple of good libraries out there, but a lot of them take a couple of workarounds. It'd be good to do something like that at some point, I guess. But then at a certain point, you could probably just get someone who writes better code to do it. Yeah.
Hey, thanks for the talk. It was cool. I was wondering, maybe you could circumvent the animation curve problems by wrapping each one in a scriptable object, because I think then you could change it while it's playing. Yeah, sorry, that's not so much a question as a maybe this would
right.
work.
So you create an animation curve wrapper, which would then be like a mono behavior.
No, it would be just a Unity scriptable object, like one of those like data little thingos, and you can change them safely while the game is running.
Okay, I'll have to look into that. Thank you.
Anyway, yeah, thank you. That's the main thing I wanted to say was cool talk.
Oh, cheers. Yeah. Oh, look, it's Unity scriptable object. Okay. I hate working with those things. Oh, yeah.
Any more questions? I had a question, if not.
Yep.
Have you found, I don't think you mentioned this, but have you found it also a benefit that you've done all this work when you have multiple games that maybe this is kind of your in-house sound engine?
I mean, yeah, it's just sort of, yeah. I mean, Out of the Rail was very quick to spin up. I think we had sound playing in that game in about a week, because we could basically drag all the. We just use pooling for Out of the Rail. We don't have any, because there's trains for days. It's multiplayer, so we can't have audio sources on trains. So everything is pooled. So we were able to spin up that in a matter of days, thanks to having that existing code. It's not a library because we tend to develop in a fairly ad hoc format at Rocketworks, at least for Unity. But yeah, it was a bit of a copy pasta. Yeah. Time? Sweet. Thank you very much. Thanks for coming.